Hello and welcome to another video. In this video we're going to be working on contiguous array, and in the problem you're given a binary array nums and you want to return the maximum length of a contiguous array with an equal number of zeros and ones. So in this first example, the longest array possible is this, so you just want to return 1 here, and here the longest array is either this or this, so you want to return 2. So actually, sorry, you want to return 2 here because the longest array is 2, and the longest array here is 2 as well. So, and the constraint is 10 to the 5th, so we're looking for like an n log n or something, or n. So one thing you could do that will give you a TLE, but a brute force, is just like start at every index, and then just go down and count up how many ones and zeros you have, and just store the longest one. So like in this example, we'd be like, okay, we start at this first index, we get, this is 1, so this is length 2, we get 1 here, length 4, here's another one of length 8, and that's it. And then we do the same thing here. So like here's one of length 2, length 4, length 6, length 8, and that's it. And so on and so on and so on. And you could do that, but that's going to be unsquared. So the key to this problem is basically realizing that to know if the count of zeros and ones is the same, you basically just have to store the count of zeros and ones, and you're looking for a difference of zeros and 1 to be the same. So like 1s minus zeros or zeros minus 1 needs to be the same. And you could, honestly, to make it even simpler, you could change these zeros. So every 0, we can just change it into a -1. And it's basically the same problem. And now we are asked, give the longest subarray of sum 0, right? So find the longest contiguous subarray that sums up to 0. Because if the numbers of 1s and zeros are equal, that subarray will sum up to 0. So for example, like this sums up to 0. So this is a subarray that sums up to a 0 right here, and so on. And we can basically use that. So we don't need to change the 1s to zeros, but we can do this as we calculate. So we can say, like, if we have a 0, let's subtract 1. And if we have a 1, we'll add 1. And we're looking for sum arrays with sum 0. And now you're, like I said, the problem is basically find the longest contiguous subarray of sum 0. And the way to do that is, like we've done a couple other problems this week, is just a prefix sum. So what you are looking for is you store prefix sums, and basically if you have some number, like let's say here, like every time we get a 1 we'll add 1, every time we get a 0 we'll subtract 1. Let's say here, this is obviously not going to be the right answer, but let's say here our total is like 7. And then here our total is also 7. That means that for this whole array, this whole total has to be 0. So anytime we hit a sum that we've seen before, the array between those two is going to add up to 0, meaning the number of zeros and ones are equal. And so that's kind of what we're looking for. And now the other thing is we're looking for the longest one possible. So what we can do is like let's say this sums up to 7, this sums up to 7, this sums up to 7, and now we're here, and this also sums up to 7. So any one of these arrays would add up to 7 now. So like this would be 7. Or sorry, not 7, 0, right? Because in order to go from a 7 to a 7, you have to basically add 0. So the middle part is going to be 0. So like this sums up to 0, this sums up to 0, this sums up to 0. Basically, you can take any two of these and make a contiguous array that sums up to 0. Obviously, these aren't equal to 7, but if they were. So, but because we want the longest one, we're always just going to want to pick our current index and the farthest left index that we have. That is some sum. And so that's kind of the idea. We don't need to store every number. Like we don't need to store the index for every number. What we do need to do is we basically have two cases. So case 1, seen the sum before. In that case, we can make an array from our current number to where the index is where we've seen the sum before. And that's going to be like the biggest array we can make using that index. 2, haven't seen the sum. Then we just store that index. And so by doing that, we're basically going to store the leftmost index where we get every single sum. Because we don't really care, like if we have a bunch of different places that add up to some number, whenever we're at some number that has some sum, like it says this is 7, we really want to make an array with this and the leftmost 7 available, because that's going to be the longest one possible. So it's very similar to the other one where you want to count up, like the number of arrays do something. Now instead of counting up, you just store the index of the first one you see. So let's kind of walk through this and how this would look like. So once again, for the prefix sums, you want to start with a sum of 0 and index -1 because you want to include like the empty array and the full array. Like let's say this whole thing adds up to 0. now you're going to be like, or actually this whole thing adds up to 0. You're going to be like, have I seen a 0 before? Yes, it's over here. So my array is length 2. And if you didn't have this stored, then this wouldn't work. So we're going to say we have a sum of 0 at index -1. We just want to store the leftmost index. So let's just like walk through this. Okay, so here our total is 1, right? We're just gonna keep track of a cumulative total as we go. So so our total is 1. So let's just write it like here, like total equals 1 or something. And so have we seen 1 before? No, we haven't. So we're gonna store 1, and that occurred at index 0. So over here, our total now is 0. Remember, every time we get a 1, we will add 1. Every time we get a 0, we will subtract 1, because we're basically trying to look for arrays that sum up to 0, and we can do that by subtracting 1 every time we get a 0. So now our total is 0. Have we seen it? Yes, we have. We've seen it at -1. So the length of the array here is 2, right? Because we've seen it at -1. We're currently at index 1, so it's this array here. So it's just the current index minus the index we've seen it last. That's why you want to put in this -1 to start off, because that will make everything work out. So basically here, our result, we can write this here, our result will equal 2. And we don't want to store this, right? Because we want to only store the leftmost index where we see every sum. So we can store this, but the leftmost index is over here, and that's the one we want to keep. So let's keep going. So now our total is 1 again. So we want to see, have we seen this before? Yes, we have. We've seen it at over here. So this is going to be the current index, which is 2, minus the index we've seen it before, which is 0. So that's going to be 2, and our result is already 2, so it's the same length array, and that's going to be this array here. And we don't need to store it, like I said, because we want to store the leftmost index where we have every sum. So over here, our total back down to 0. Whoops. Okay, so our total is back down to 0. Have we seen it before? Yes, we have at -1. So now this is 3 minus -1, which is 4. So now our result is 4. And we can write it in here. So our result is 4, and that's this array here, right? Like we've seen this 0 over here. That means this whole array. Basically, your array is the array, like you look at where's the last place you've seen it, and the array is every number after that up until and including your current number. Okay, so our result is 4, and our total is 0. So let's keep going. So now our total is 1 again. So our total is 1. Have we seen a 1? Yes, we have. We've seen it at index 0. So that means we can make this array here. So it's going to be 4 minus 0, which is length 4. We already have a 4, so we don't have to do anything there. It's the same. So here, our total now is 2. So we're going to store 2. And we're going to see, have we seen a 2 here? So we haven't seen a 2. So we're going to store it. So 2, and we've seen it at index 5. Now you could do some like early break conditions too, where like if your result's like big enough, you might figure out that it's not possible to make anything better, but it's kind of not necessary. So we'll keep going. So for a 0, we'll subtract 1, so now our result is 1 again. So have we seen a 1? Yes, we have. We've seen at index 0. So that means we have 6 minus 0, which is this array here, and that's length 6. So now we have a better result, so we will update this 4 to a 6. Then we keep going. So we have a 0, so we'll subtract 1. Our total is 0. Have we seen that before? Yes, we have at -1. So now our total is 7 minus -1, which is 8, which is this array here. So 8 is obviously better than 6, so we will update it to 8. Then our total is 1. Have we seen it before? Yes, we have at index 0. So we have 8 minus 0, which is 8, and that's 38. So it's the same thing. And then finally, our total is 2 at the end. Have we seen a 2 before? Yes, we have at index 5. So we have 9 minus 5. So that's going to be length 4, and our result's better. And that's this array here. So you can see, like, you basically look at the location where you've seen it last, which is over here, and the array is always going to be every number after that up until and including the current number. And so we return 8 because that's the longest array we found. And that's how you do it. It's very similar to other problems, as long as you just recognize that I want to store the leftmost index. And this 1s and 0s is basically the same thing as give me an array of some 0, where for a 1 I add 1, for 0 subtract 1. You could do it the other way, like for 0 you add 1, for 1 you subtract 1 or something. Doesn't really matter how you do it, but either one of those works. So we can code that. So we're going to say prefixes, and we are going to start with a dictionary of a sum 0 at index -1. then we are going to have a result, and we're going to have a total. And so we'll say for I, v, and enumerate nums. So we are going to add to the total. Oh, this is not tabbed correctly. So we're going to say total plus equals value. And basically, if we've seen it before, then we're going to check our result. So if total in prefixes, then we can just maximize the result. So our result is going to be maximum of the old result and I minus the old, where we've seen this total in the prefixes, so prefixes total. Otherwise, we're going to store it in a prefixes. So otherwise, prefixes total equals I. And like I said, if we already have it in, we don't want to store it again because we want the leftmost location of this value. And we can just return result. And run this and get an error. Interesting. Let's see, so we got 1 and we are expected 2. So let's see what we did wrong. Result total 0 at -1. Okay, so total plus equals v is fine. If total in prefixes, result equals I minus prefixes total. So this should return 2 for sure. So why is it not? Let's figure it out. Else prefixes total equals I. That should be fine as well. Let's print prefixes. Probably some super silly mistake as always. So 0, -1, 1, 1. So we should have a 0. Oh, right. Yeah, okay. So what we did wrong was we shouldn't just be adding the value. We should be adding 1 if it's a 1, and we should be subtracting 1 if it's a 0. So here we can say 1 if v equals 1, else -1. If it's a 0, we want to subtract 1. So now we should get the right answer. Okay, there we go. And yeah, so this is going to be time of n space of n. Yeah, because for prefix sums is of n. So yeah, pretty much as good as you can do for this problem, I think. I don't think you can do it in like O1 space or anything. But yeah, this pattern, we've seen it like 3 times now, I think, in the last week. So it's kind of just a repetitive, like, can you figure out how to get a subarray of sum in constant, or not in constant time, but can you get all of those in linear time? And you can using prefix sums, just with a slight modification every time. So yeah, that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.